Okay, we rolling. These are little Doppler radar boards I got to experiment with. Super cheap. Money's tight right now, so my funds gotta be super cheap. And what I'm gonna do is I'm gonna demonstrate how to solder these little guys. Now, I forget exactly what the internet thinks these are supposed to be, but they are. Let me see here. It's hard to read. It says RCWL0001 on the chips. That's kind of ridiculous. I believe. Oh, there it is. Okay. RCL. Where's my. Ooh, there we are. RCWL0516 plus. So, what you need to do straight away is you need to solder pin headers onto these. Just makes it easier than doing wire because now you can just ram them into a breadboard to do all your playing around, which there will be some considerable playing around before I'm where I want to be with these. I am not doing the stupid thing with the LEDs. I look at that and I think, damn man, that's like really limiting yourself. Pin 12 on these chips offers you the ability to sample the direct analog signal out, so then you can couple it into a circuit of your choice instead of just turning an LED on and off for 2 seconds, which tells you nothing. So that's what I'm going to be doing. So I'm going to keep it breadboarded because I want to go pretty far with these. Same way I did the PIR sensors when I was first playing with those. Okay, so over yonder, you can't, sir, not appearing in this film. I've got a Weller WES51 soldering station. I have turned up to 70 on the temperature dial, which is basically 700 degrees Fahrenheit. Now, I'm actually going to turn that down a bit because I feel like that's overkill, so 650. That gets you right on the line between, quick flow and lack of damage to your please don't lose focus. Okay, locked. Damage to your device / components. So, quick rub on the damp sponge, which is just a piece of crap kitchen sponge from Wally World. Press hard against the pin and the joint at the same time and just feed in solder, and there you go. Nice clean weld. Now I got a little tiny fleck of solder on there. That's good. You want that. So when you press, you've got insta contact. Sorry, my hands are shaking. That is the normal state of affairs with me, which is why I can't do this professionally. And also I'm caffeinated to the sky here, which doesn't help anything. Anyway, so use across. Always good to make sure you're a little wet first on there, so you're not keeping hot contact too long. Delicate parts, And there you go. And I'll just go across each really quick. And you notice when I release, I don't just pull away, I fleck upward. Keeps the joints a little cleaner. And there you go, that's it. Now, one thing I want to point out here, to make it easier to do the work, to make it flat and stable, there are 2 end holes here. See on the corners? I got 2 pieces of my pin headers in holes in the board to prop that up, so it is nice and level and flat. The end result is this. Easy peasy. Now, it's not the strongest thing ever in the world, but it will work. It'll work just fine. It just plugs right in like that. And then hopefully that's not going to cause a problem, actually. But even if it does, like, the board obstructing the unit. Even if it does, all I have to do is like stick it on like way on the edge there, and now it's hanging off, so the antenna section is free and clear. Sorry, there you go. And it is out of focus because it's locked, but here, like that, and presto, there it is. 4 more of those, and I'm ready to start testing. First tests are going to be, of course, the LED variant, because that's just simpler to throw together. But after that, I'm going to carefully touch a wire onto pin 12 and use that as a jump point to get at the analog out. And that's going to go into the GPIO of a Raspberry Pi or Arduino, so I can then build programming around that varying Doppler shift signal and process it the way I want to. Otherwise, think of it this way. It's by default going to turn on for 2 seconds and turn back off. How are you going to discriminate between a real signal and a glitch, a power glitch, or, something you moving in the room? Because I hear these are ridiculously sensitive. No, you want to be able to see the intensity of that triggering signal. You want to see it move in real time. You want to see the frequency and intensity of the detected signal. That's how you do processing, not with an on-off switch. Because, dude, you keep it set up with an LED on it, or like some transistor activation or whatever. 2 seconds for every stupid thing. That's just obnoxious. As one guy put it, I saw on YouTube, I'm not sure what you do with it. Yeah, well, I'm not sure either when everything's a 2-second trigger. So, analog. Always analog. Much better. And easy to get at, especially with an Arduino. They have native analog input. Anyway, babbled enough. There's your little demo, and we'll be moving on. Thanks for watching.